Hello there, welcome to Ethio-Hahu tutorial. Today we are going to see about exponential functions. Let's see the definition of exponential functions. A function of the form y is equal to f of x is equal to a to the power of x, where a is greater than 0 and a different from 1 is called an exponential functions. The domain of an exponential function is the set of all real numbers. That is, the domain of this exponential function y is equal to a to the power of x is a set containing x such that x is an element of all real number, or the ordered pair from negative infinity to positive infinity is the domain of the exponential function. The range of this exponential function y is equal to a to the power of x is a set of positive real numbers. That is, range is equal to the set containing y such that y is greater than 0, or an ordered pair from 0 to positive infinity. Having seen this definition, let's see properties of exponential functions. The first property, a to the power of x times a to the power of y is equal to a to the power of x plus y. If they have the same base, we can add simply their exponents. The second property, a to the power of x over a to the power of y is equal to a to the power of x minus y. Or this can be simply 1 over a to the power of y minus x. A to the power of 0 is equal to 1 for a different from 0. If a to the power of x is equal to a to the power of y, then x is equal to y. The exponents are necessarily equal. If a to the power of x is equal to b to the power of x, then necessarily a and b are equal. A to the power of minus x is equal to 1 over a to the power of x. These are the properties of exponential functions. Let's see graphs of an increasing exponential functions and decreasing exponential functions. A function is said to be an increasing function if it increases with x. As x increases, if y increases, then the function is said to be an increasing graph. Or an increasing graph should have a positive slope. Therefore, a function of the form y is equal to f of x is equal to a to the power of x is an increasing function if a is greater than 1. If the base a is greater than 1, then it is an increasing function. To see that, y is equal to f of x is equal to a to the power of x. When x is equal to 0, y is equal to a to the power of 0 is equal to 1. When x approaches to infinity, positive infinity, y approaches to positive infinity. When x approaches to negative infinity, y approaches to 0. To draw the graph of this function, this x-axis, this is f of x. When x is equal to 0, f of x is 1. When x approaches to positive infinity, y approaches to positive infinity. And when x approaches to negative infinity, y approaches to 0. Therefore, this means x-axis is the horizontal asymptote. That means the graph increases like this. This is f of x is equal to a to the power of x for a greater than 1. And this is an increasing graph. Example, let y is equal to the power of x plus 1. Find the domain, range, intercepts, asymptotes, and draw the graph y is equal to the power of x plus 1. Y is equal to the power of x plus 1. First, domain of f of x is equal to the set of all real number. That means from negative infinity to positive infinity. Second, range. Range is equal to the set containing y such that y is greater than 1. That means when x is equal to negative infinity, or when x approaches to negative infinity, this approaches to 0 and y approaches to 1. Third, intercept. Y-intercept. X is equal to 0. Y-intercept is obtained when x is equal to 0. That is, y is equal to the power of 0 plus 1. This is equal to the power of 0 is 1. 1 plus 1 is equal to 2. Therefore, y-intercept is equal to 2. Fourth, the horizontal asymptote is obtained by letting x is equal to negative infinity or positive infinity. As x approaches to negative infinity, then y approaches to 1. As x approaches to negative infinity, limit of f of x as x approaches to negative infinity is equal to limit of to the power of x plus 1 as x approaches to negative infinity. This is equal to 1 because to the power of x approaches to 0 as x approaches to negative infinity. 0 plus 1 is 1. Therefore, the horizontal asymptote is 1. Therefore, the horizontal asymptote is y is equal to 1. Now, let's draw the graph. To draw the graph, this is x-axis, y-axis. The y-intercept. The domain is the set of whole number. The range is y greater than 1. The y-intercept is 2. This is 1. The y-intercept is 2. The horizontal asymptote is 1. Y is equal to 1. The graph looks like this one. The graph looks like this one. This is f of x is equal to y is equal to the power of x plus 1. Graphs of a decreasing exponential function. A function of the form y is equal to f of x is equal to a to the power of x is a decreasing function if a is between 0 and 1. That is, f of x is equal to a to the power of x if a is greater than 0 and less than 1, as x approaches to positive infinity, y approaches to 0. As x approaches to negative infinity, y approaches to positive infinity. When x is equal to 0, f of x is equal to a to the power of 0, which is equal to 1. Having this, let's draw the graph. When x is equal to 0, f of x is 1. When x approaches to positive infinity, y approaches to 0. When x approaches to negative infinity, y approaches to positive infinity. And when x equals 0, f of x or y is equal to 1. This graph is a decreasing graph. And the horizontal line, x-axis, is a horizontal asymptote. X-axis is the horizontal asymptote. And this graph is f of x is equal to a to the power of x, where a is greater than 0 and less than 1, between 0 and 1. And this is all about exponential functions, and next time we'll see another topic. Until then, have a nice time.